so welcome to our virtual ID table, which is, I feel like maybe meta virtual this month, because it's not just emailed photos, it's photos from our iNaturalist website mostly, although a few email submissions as well. I'm very happy to be pinch hitting for Mitch, so thanks for bearing with me. It's my first time doing it, but I'm pretty excited. So just in general, I don't know how many folks know about iNaturalist, but it's a great citizen science website. And, you know, it's not just mushroom focused, as I think Elizabeth mentioned. It looks at all different kinds. Sorry, my parents are walking around in the background. It looks at all different kinds of, you know, different kinds of life, actually. You can even tag something as state of matter life. But anyway, so we have our own project for MAW on iNat, and I just wanted to show people how to find it. And basically what you do is, if you go to inaturalist.org and you search in the, you just type in mycological association, and we pop up once you get a few letters in. So basically where I wrote type here, and then you click on the about to see the information about our project. And so then you would basically be brought to this page. And if you want to join the project, you can see, hold on one second, sorry. Okay, sorry, my son is in the background. So if you want to join, you basically click here where it says leave for me, because I've already joined. And as you can see, we have you know, a bunch of members, but I think 95 members, but what our club has like hundreds of members. So there's definitely room for more participation, and we would love to have more folks join. And what do you get from joining? Well, it's pretty cool. You can see all the recent observations of other club members, which I love to troll looking to see what's popping up. It's really fun and exciting to live vicariously, particularly on days when, you know, you have to have work meetings all day. Like today, I really didn't get out at all. I was so happy to get to see what other folks are doing. And you can learn really about your local species, which is kind of cool. So it gives you some interesting stats on the most observed species. So you can see, I mean, in some ways, it may be also most easy to ID species, like turkey tail is, I guess, you know, fairly easy to ID, and as is false turkey tail. But, you know, a lot of the other species I think are very common, like I think Pleurotus and, you know, some of the other ones in there. Certainly the Trametes species are all pretty common. So that's interesting. And you can also learn a lot about your local habitats through using this project, because as you can see, if you scrolled down in the page, you would see this map, and the map kind of contains all the different counties that are included in our project. So basically for the 95 people currently in the project, like for me, if I make an observation, you know, of a fungus anywhere in these counties, then it will pop automatically into the project. I don't have to add it or anything, which is great. It just gets kind of sucked up. Right now, I'm actually in Massachusetts, in Cape Cod with my family, which is why people are walking around in the background. And I'm making observations here, but they don't go into the project because obviously they're irrelevant to the DC area. But it's fun because even within this table, you can, even within this map, you can see there are definitely different microenvironments, and you can kind of zoom in on them to get more information. So I was going through our recent observations, and some themes emerged. So I decided I would start off by showing some observations of oysters and empoisters. Pardon my pun. Obviously revealing my terrible sense of humor, but anyway. So I don't know who I will say I don't know who every iNat person is. Some of you I know IRL, that means in real life, and on iNat. And I also have friends who I kind of didn't know IRL, who I met through iNat. So I would say also it's a great social community of people who are similarly obsessive and, you know, excited by being outdoors. So it's a nice resource for community as well. So A. Perper made this observation just about a few days ago, last week. And this I don't know. I was going to say, maybe not for this one. For other ones, I might have people make guesses, but this is Panis lecomptii, and I'm going to probably pronounce things wrong. But you may see this in your books as Panis neostrigosus, but it's basically called the hairy oyster mushroom. I don't really know. It doesn't seem to me like an oyster mushroom, although I think it does smell kind of the cucumber watermelon-y smell. So maybe that tricked people. But frankly, you know, if you've met this mushroom in person, it's not the kind of mushroom that you would think about eating. It's like very tough and extremely hairy. But I guess if you're really hungry, maybe you would. Interestingly, though, it is a gilled polypore, so it's not even in the same, you know, order as oyster mushrooms. And it's really notable for its hairy cap. So then my buddy Rachel Courtney did a great observation of a very similar looking mushroom. And okay, so now I am monitoring the chat. Does anybody feel like throwing out the name of this one in the chat if you happen to know it? No worries if you don't. Just give it a second. Okay, well, this one is very similar in color, very similar gills, but you can see that the pileus, the cap, is totally different texture, right? So this is Panis concatus, which is, you know, the same genus but a different species, and it's the common name is the lilac oysterling, and it's also a gilled polypore. But really, the notable thing is that it's very smooth, unlike the other one, which was extremely fuzzy. So next, I have a couple of lookalikes, and I wonder if anyone wants to guess which of these is the edible oyster mushroom. You could just say left or right for your left or right. So which one is edible? Anyone want to vote? It's okay if you, I don't want to put people on the spot, but yeah, yep, okay, good. So everyone's on top of it. Perfect. So we're seeing lots of lefts, as we should. But you know, you could imagine that, I mean, honestly, like, I think anyone can get tricked. I've certainly been tricked from afar. And I think also when you're just getting started too, it's pretty easy to get tricked, like if you haven't seen a ton of Pleurotus species. So the first one on the left, like everyone said, that's one of the edible oyster mushrooms, Pleurotus. And I'm saying, like, basically compare it to Pleurotus pulmonarius, although frankly, like, I think from a DNA perspective, it's unclear what species we actually have and whether they're different. But the other one is a Crepidotus species, which is an oysterling is like the common name. And you can see from looking at this picture that there are some definite differences if you look closer. Yeah, you do see those the fungus beetles who love to eat it. Hold on a second. You guys, you have to be quiet. Thank you. Sorry. So interestingly, on the Crepidotus species, you can see probably some of the other mushrooms drop their spores on it, because you see that there's like this pink kind of glow on it. And then I think the other thing you can see here is it's stipitate. So it has a tiny little cute stipe. And you know, those are some ways that I would distinguish it. Also, it's usually like a lot thinner and doesn't really, not as meaty and delicious seeming. Okay, so next, oops, backwards. Okay, so next, yeah, this is from Matt Cohn, Elizabeth Hargrave's account, both of these, and I thought these were two nice sort of lookalikes of each other. And I guess theoretically, honestly, I probably, when I first saw these, I wouldn't have thought either of them was an oyster, I would say, but I do think they could be confused with each other. So I don't know, anyone want to guess which one is the edible oyster on this one? Okay, so Ami said elm oyster left. It is, the left is correct, but it's not the elm oyster, which would be like Hypsigeus. I can't pronounce anything. Ulmarius. So this is actually Pleurotus levis or levis. I don't know how you pronounce it. On the left. Now Elizabeth and Matt ID'd it as Pleurotus dryanus, and I guess it's possible, but some people like Jacob Kalichman, who's way smarter than me, has done a bunch of like macro comparisons and DNA comparisons, and he's pretty convinced that most of the sort of fuzzy stiped, big, chunky oysters like these that we have around here are probably Pleurotus levis or levis, I don't know, rather than dryanus. So that's why that's why I did it that way. But honestly, like tomato, tomato, but definitely not tomato, tomato with Neolentinus lepidius, which I think has been shown here before, but that's the train wrecker mushroom. And you can definitely tell it apart. If you look closely, I zoomed in to show that it has these serrated gills. So serrated as in like almost like someone took little jagged bites out of them. And this one is a really tough mother. It's like you would not want to bite this guy. It's like an extremely tough mushroom. And I think it's so tough that they break through the cresoide or creseode, I don't know how to say that, but the things that put railroads together. So that's why it's called the train wrecker, because it used to cause train wrecks. So beyond that, I have a few other cool observations that are not oysters or impoisters. And this is just a picture that Tom McCoy sent in of an incredibly luscious ramp field that he was with the other day. So I thought this one was fun. You know, the first person, Phoebe's mom, which keeps making me have that song Stacy's mom in my head. And then the bottom person is by me. My name on INAT is We Are the Champignon, and please, you know, follow me or I will follow you. Love to look at people's observations. Feel free to tag me in things. You know, I may not know the answer, but if you do We Are the Champignon in your comments, I'm always happy to look at it and ask smarter people. Oh, okay. Someone said train wrecker can be tender enough to eat when young, but not very tasty. That's interesting. I did not know that. I don't think I'd go for it. So these two are both stinkhorns, and I can tell you mine on the bottom, I smelled down the block before I even came close to it. Like I was like walking my dog down the block and I smelled something terrible. And I was like, there's a stinkhorn in this town. And then I went and I looked and I actually found it. So that was an interesting experience to smell it before you find it. But these two are sort of lookalikes. So let's see, the first one is Phallus rubicundus. And you can really tell it apart from the other one because the gleba, which is like the gross smelly stuff at the top that attracts all the flies and spreads the spores, it's really separate from the stem or the stipe. So it's like a hat, you know, like a little cone hat. Oh, you didn't smell them. Kristen said they smelled them, but they didn't smell bad. I don't know. I mean, I don't know if this is like a personal thing. I have a pretty strong sense of smell, but like I can't even collect these because if I put them in my car, I will throw up. It smells so bad to me. Anyway, so Phallus rubicundus does have this separate hat, which is sort of how you can tell. It has a pink or red stem when it's fresh. If it had a more orange stem, it would be a different, potentially a different Phallus species. And it has a white vulva, meaning like the egg that contains it and that it kind of grows out of, and it can stain brown. Whereas this was the one I saw or smelled in my neighborhood. And in this one, Mutinus elegans, there is no hat. So the gross brown stuff is just stuck directly on the upper part of the stem. And the stem is bright orange when it's fresh. If it were a red stem, it would be a different Mutinus species. And the vulva on this guy, you can't really see very well here, but it is more pinkish or purplish than just white. So those are all ways you could tell them apart. Okay, so this is my real excitement. I made an observation of the month. It's not my observation, but I was so thrilled to see this observation because it was just so high quality. And one of the things on iNaturalist that, you know, make it really good is if people take pictures, more than one pictures from multiple angles. It really helps to see the fertile surface, meaning the pores or the gills or the teeth or whatever. If it's an asco, you know, whatever, all sides of it. And there are other things that are helpful too. So this person did just like a really sick observation. So Marilyn Cat made this observation in Fredericksburg, Virginia. And, you know, you can see that she put in 4 different pictures and really clear pictures. that showed important features. So particularly, I'll say this is a bolete. For boletes, very important to see the texture of the whole stipe, and especially where the stipe meets the pores. Really important to see the pore color, but also there are other pictures that I'll show you in the next slide. Just to tell you guys, looking at this, I'm noticing there isn't a lot of ornamentation on the stipe. So sometimes with the boletes, you'll see there's the netting or reticulation. Sometimes there's dots, which are like punctae, or there's scabers, which the Lexinum species have, that are these kind of roughened patches. This doesn't really have any of those. It looks like pretty smooth looking. And then I'm looking at the pores and I'm seeing they look kind of yellowish, brownish. And they almost look a little like coffee in terms of the color. So this is Xanthoconium affine, or affine, or whatever. And so I thought, Marilyn just did these excellent pictures because you can see the cap here. You can see it's a little cracked and brown, and it's not sticky at all like a Suillus would be. It's certainly dry, maybe a little velvety. You can very clearly see the stipe doesn't have any ornamentation. And then she did even one better. She scratched the pores. So I think here you can see she scratched the pores to see if that changed colors. Boletes often will change colors, although this one didn't really. But other species do. Oops, sorry. And then finally she did a cross section, which is like golden. So really appreciated this observation. It was super easy to ID. Unfortunately, it's a choice edible, but as you can see, the bugs ate it before Marilyn found it. So next time, Marilyn, keep an eye on that spot. And then a few email submissions. I thought this one was really so funny. April sent this into Mitch, and Mitch and I were emailing. I mean, we think it's probably a slime mold, but frankly, I don't know which one, and I don't know if he knew which one either, but it's hilarious picture. I love it. So the first one, this one is really cool. I actually maybe forgot to write down who sent it. So if you sent it, feel free to say it in the chat, but this is really neat. I remember it came from, oh no, wait, maybe was this Mary in Roanoke, I think. Pretty sure this was Mary in Roanoke. Sent this really cool one. If you saw this, you'd be like, what the heck is that? Well, it's actually an Acanthamyces species, and that's one of the cordyceps family. It's called an entomopathogenic fungus, meaning like pathogenic to bugs. And it hold on a second. You guys, can you please be quiet? It parasitizes bugs like spiders, moths, butterflies. And Mitch, I can't remember which species you had suggested. I think you're probably right. I think it was with something with an A, but I looked it up and it seems like you probably need really micro to confirm. So if anybody finds one of these and you want someone to do micro on it, feel free to send it to me because I would always love to look. So I thought that was just a really neat observation. And I know a lot of people who have this high on their bucket list, they would be thrilled to find it. So nice work, Mary, on that one. Very cool find. So this is also from April, and I think this is the last one of the night, or the last two rather. And another kind of fun comparison. So these are ink caps, as you can see, and you can kind of see that the ones on the left, actually, and the ones on the right, both are starting to deliquesce. A different April, okay, are starting to deliquesce a little bit, meaning like they're kind of liquefying. And I know we've probably talked about that before with ink caps, but it's just some of the ink caps do this and it's really cool. They just like liquefy and their spores mature, and that's how they spread them around. So these are in the same kind of group. So I would refer to them as like the Coprinopsis, variegata, strossmayeri group. And I would say more about that, but it's actually a spoiler for what Megan is going to talk about a little bit later. So stay tuned for more on this species group. But I was super pumped to see these two. And I will just go back and show you that I think even though these look quite similar, there are some clear differences between these two. So if you look at the scales on the one on your left, there are many layers of scales, like certainly more than 7, maybe even like 10, if in terms of like 1, 2, 3, that kind of layer. Whereas if you look at the ones on the right, the scales, there are very few. I think, maximum maybe like 3 or 4 layers of scale. So it's very different the way that has happened. And, they didn't dig these up, but if you did, some of them have like really copious rhizomorphs or roots, and some of them don't. And so there are all these different kind of macro features that can be helpful if you're in Europe for telling these apart, but things are more complicated here in the US, unfortunately, as they usually are. And I think Megan will talk a little bit about that. So anyway, stay tuned, but I thought this was super cool. So April used these to do some art. So basically, as I said, they delacrest, and I think if you take that ooey gooey, creepy black liquid and mix it with water, it apparently makes an excellent watercolor. So I thought this was a great note to end on. And just looking at the questions now, if we add some photo observations on iNut, how do we alert you that they are there if we'd like them to be ID'd? So I do try to troll the website, so I will look at things, but if you specifically want help with something, please tag me. I'm just gonna write how you would tag me. You would write at We Are the Shem. If I could spell my own tag, We Are the Shem. If you put that in the comments, it'll definitely draw my attention to it. It'll send me a little message. And I mean, I really might not know what it is, but I can definitely tag other people who would. So just tag that in the comments. And it just, if you look at our project, there's a lot of things that are not necessarily ID'd there. And there are a lot of reasons for that. So some of it may just be the quality of the observations. So I see stuff all the time where I'm like, that's probably this. Like I saw some today that's probably lacrimaria, see some that are probably something else. But if I don't actually see like the gills, sometimes I'm like, I feel bold, I'm gonna, put something on it. But a lot of the time, if you can't see the whole thing, you don't want to go out on a limb and make a bad ID. Oh, sorry, I may have left out a letter. Yes, oops, thank you, Elizabeth. Yes, let me write that again. I knew I would misspell my name. And yeah, there we go. Yes, that's correct. So yeah, it could be the quality of the observation. It could be that people just don't know. It could be that some things can't be ID'd to species based on pictures. So for example, there's been a lot of agaricus popping up, and I didn't include any of them in our presentation because really very few of them can be ID'd to species without microscopy and DNA, and often with microscopy and DNA, you still might not be able to, because a lot of unnamed, or kind of undescribed species,